Hello Legacy Sabers, Marsh here. So today we're going to solve exponential and logarithmic equations. So finally a reason we're going to learn about exponents and logs today. You're going to want your notes, calculator, and then you're going to want a pen or a pencil as well today. So to solve an exponential or logarithmic equation, there's some things we're going to need to be able to know we need to know how to do. We need to know properties of exponents. We need to know how to change to log form. So the idea of going log base 2 of 16 equals 4, and also the idea of ln of 148.4 equals 5. So being able to convert between forms. Something we really haven't covered exactly, but we kind of have. Understanding the exponentials and logarithms are inverses of one another, kind of like adding is the inverses of subtracting. We're going to be using this to solve today. And then also the change of base formula. So if I have log base 5 of 13, that is log of 13 divided by log of 5. This is so you can get this into your calculator, because not all calculators have the ability to do a log of every single base. So, two different kinds of exponential equations that we need to talk about. One with exponents on both sides, and then one with exponents on only one side. One with exponents on both sides, what you're going to have to do is thinking about making things equal to one another. So I have 3 to the x equals 3 to the 5th. Well, notice guys, I have the same base on both of these sides. That's not going to matter. I do not need to worry then, because all I need to worry then is about making our exponents equal, right? Because if I have 3 to the x equals 3 to the 5th, that means that x has to be 5. Because my exponents have to be equal to one another. So what if I try 9 to the 2x equals 27x to the negative 1? I need to get exponents, these two bases need to be the same. So what base does 9 and 27 share? Well, they both share a 3, right? Because 9 is technically just 3 squared, if I would write it like that, times 2 to the x. And then 27 is just 3 cubed, like that. 3 cubed is just 27. Notice, guys, now I have the same base. I am able now just to worry about exponents. So I can go 2 times 2x, that's 4x. 3 times that, that's 3x minus 3 after doing distributive property. Subtract 3x from both sides. Now I get x equals negative 3, which you can plug in, check to see if you get the same answer on both sides, and in fact you do. Now, what about exponents on one side? What you're going to want to do is get the parent, the 2 to the x, on its own. So I'm going to add 1 to both sides. Now I got 2 to the x equals 7. Now, here's where those inverse operations come into play. So, exponentiating 2 to the x. That, to do an inverse operation on that, what I'm going to do is go log of the base. Log base 2 on both sides. I'm going to take a log of both sides. Now, remember guys, our properties of our exponent, or properties of logs, this x can drop down in the front now. Because I got x times log base 2 of 2 equals log base 2 of 7. Well, log base 2 of 2, all that is, guys, is 1, right? Because 2 to the first would equal 2. So technically I have x times 1 equals log base 2 of 7. So to solve for x, technically I divide by 1, which is nothing, so I can go x equals log base 2 of 7, which into my calculator, so I can actually get a decimal approximation, I will go log base 7 divided by log base 2, and I get a value of 2.81 for x. Pop over to the next. So the idea of doing inverse operations to get rid of the exponentiating. Notice, guys, sidebar here, if I would just convert this, because I had 2 to the x equals 7, I could convert that into log base 2 of 7 equals x. Notice that's exactly what you got right here after doing exponentials on both sides. That's why that conversion that we've been doing, that's why it works, because logs and exponentials are inverses of one another. So when rewriting, you could actually take a log of both sides and you would not be wrong when you're writing from exponential to logarithmic. Or if you do not like the whole log both sides, if you are really good at the whole conversion like this, you can do it that way as well. More than one way to solve these today. Now I have 3 times e to the x plus 1. So we need to get e to the x alone. He needs to be alone. So I'm going to subtract 1 to both sides. And I get equals 84. Looks like I got to divide by 3. So I got 84 divided by 3. That is 28. So I'm at e to the x equals 28. Now, I'm going to log both sides. But remember, guys, I'm not just going to log both sides, because the opposite of e, the log version of e, for e is he, ln. So I'm going to ln both sides, actually. My x is going to drop out in front using properties of logarithms. Natural log of e, that is technically just 1. That cancels off. So I'm left with x equals the natural log of 28, which in this case has a value of 3.33. So x equals 3.33. Sidebar conversation over here quick. As I'm at e to the x equals 28, I can convert that into exponential or logarithmic form. ln of 28 equals x, because this is technically log base e. Same thing, you got the same answer as what I did, 2 different ways to do the same problem. Now, let's take a look at logarithmic equations. First kind, there's 2 kinds. One with logs on both sides, one with a log on one side. Let's take a look on both sides. What you're going to do is think about making things equal, property of equality. So I have log base 5 of 4x minus 7 equals log base 5 of x plus 5. Well, you're probably saying, Marsh, if I have log base 5 and log base 5, technically, I just need to worry about the insides, right? And you're very right. Because technically, log base 5, the inverse of log base 5 would be exponentiating both sides to 5. So like this. These cancel off. That's just 1. So I'm left with 4x minus 7 and x plus 5. Because they have the same base on the log. So all I need to worry about is making the insides equal to one another. I'm going to subtract x. I'm going to add 7. Divide by 3. And I get x equals 4. Now, with logarithms, exponentials didn't have this issue, but logarithms do. You need to make sure that when you plug in your value here, you do not get a negative inside the logs. Because we kind of discussed this, that logs have a domain of 0 to infinity, not including 0. You can't have a negative inside of a log. So I'll go 16 minus 7, that's 9, no problems there. Can have a 9 inside of there. And then I'll have 4 plus 5, which is 9 as well. No issues there. But with logarithmic equations, you always need to plug in your answer and make sure you don't get an extraneous one. It does happen from time to time. Now, log on one side, that's kind of cut off, but nevertheless, log on one side. You're going to isolate the log and exponentiate both sides to log's base to change into exponential form. So notice, guys, log is on his own on here. So we're going to exponentiate, aka take both sides to the same power. So I'm going to go 10 to the power of log base 10 of x and 10 to the power of negative 2. Log base 10 of 10, those guys cancel off. I'm going to be left with just x equals 10 to the negative 2. Which gives me an answer of 1 over 100. Now, if you don't like this whole exponentiating thing, this can be also converted using our conversion form. Because we can go 10 to the negative 2 equals x, and notice we get the same answer. That's why we're allowed to use the exponential. That's why we are allowed to use that shortcut changing. The exponentiating both sides is why, the reason for it. Let's try another problem. We need to get the log alone. We need to isolate him. So let's add 3 first. It's 8. Let's divide by 2 on both sides. So I get natural log of x equals 4. Now, to undo a natural log, you're going to take both sides to the power of e. You're going to e both sides, or exponentiate both sides. E and ln, they die off, kind of like I'm basically adding 5. If you have a negative 5 over there, that's all you're doing. So I get x equals e to the 4th. And e to the 4th on my calculator is a value of 54.6 after I round. Like that. Let's try another one here. So notice, guys, my log is alone, so we need to take both sides and exponentiate to the base of the log, so 3 to the power of all of that, and 3 to the power of 2. Log base 3 and 3 cancel off, so I get 3x equals 3 squared, or 3x, oh no, not 3 squared, yep, 3 squared. That didn't cancel out over there. Oof. That equals 9, so if I divide by 3, x equals 3, double check, yep, no negatives inside of there, we are good. You could also convert this using the other form, that works as well. However, if you want to use the quicker way, the exponentiating, that works too. Now, let's look at this guy. He is quite big. Now notice, guys, I have 2 logs on this side, and they are added together, which makes me kind of wondering or curious, can I condense them? Because remember, if I have 2 logs and I'm adding them together, technically I can just multiply the insides of the logs, right? That would be the multiplication or addition rule. So I can go log base 4 of x times x plus 12. That is me condensing into 1 log. I am equal to 3. I'm going to multiply this out here. So I got log base 4 of x squared plus 12x equals 3. Now, log base 4, he's on its own, so let's take to the power of 4 on both sides. So I get x squared plus 12x equals 4 to the 3rd, which is 64. Subtract 64 to the other side. I get x squared plus 12x minus 64 equals 0. And you know what's coming. Your favorite thing, factoring. So, I need to think of 2 numbers that multiply to give me 64, but add together to give me 12. Did some math quickly on my calculator here. It looks like 2 numbers that make 64, negative 16 and 4. That would give me a negative 12. That won't work. I need a positive 12. So 16 and negative 4 will get me what I want. So since my a is 1, I can jump immediately to my factors. X plus 16, x minus 4. So my 2 answers, x equals negative 16 and x equals 4. Here is where most likely you're going to get an extraneous solution. Because notice, if I take that negative 16 and plop it in right here, put negative 16 there, I get 4 to some power has to give you negative 16, which is not the case. You can never do that. Not available to you. So, negative 16 is not the correct answer. Cannot, it's an extraneous solution. Plugging in 4, no issues there. plugging in 4 here, no problems there. And technically, if I plug in 4, the only problem you're solving is 1 plus 2, and that does in fact equal 3. And that's the end of this video. We're going to spend a couple of days on this information. We're going to go over a couple of questions as well in class, just so we can get very comfortable with working with the exponentiating and logging of both sides. But until then, see you later, Sabers.